they have different uses. So forest inventories, these refer to the systematic collections of the location, composition, and distribution of data about forests and the related resources within the forests. So when you talk about forest inventory management, here we are collecting and analyzing data captured by the forest inventories. Taking a step back into time, a number of traditional methods have been utilized to capture data about forests, but these are labor intensive, they are prone to errors and time consuming, not forgetting them being tedious. The information collected because of being tedious is almost inaccurate, not up to date, and then this hinders informed decision making by the stakeholders, also affecting the economic scale through the harvesting because you don't have up-to-date or real-time information. Thus, the application of GIS capabilities will help improve the quality of data with more simplified visualization through data integration, analysis, and sharing. The objectives of this project are to create a centralized forest inventory database for collection and integration of data. Then to also create an interactive visualization platform showing different metrics around the different forest areas, for this case, particularly in Kachung. Then to monitor tree growth and forest health using remotely sensed data and change detection techniques. On the screen is my solution architecture. I will look into data collection. Here, we are going to use remotely sensed data, field data, and existing forest inventory data. Then data processing, which will include georeferencing, spatial analysis and modeling, data integration, scenario planning, and forecasting. Taking from there, I did tree-resource assessment and then forest cover classification. For tree resource assessment, I looked into volume, biomass, and carbon stock. These are a basis of the diameter at breast height for the different trees. Then for the forest cover classification, I looked at normalized difference vegetation indices. So putting tree resource assessment and forest cover inventory, I'll try to do for actual assessment. Then production of maps and an interactive dashboard will be one of the outcomes. Just to highlight some of the GIS capabilities utilized in forest inventory management and planning. We have data collection and field mapping. Here we put to use the ArcGIS field maps, survey 1, 2, 3. Then we have the forest stand mapping and classification, putting to use the ArcGIS Pro, remote sensing and image classification, and NDVI and other vegetation indices. We also have growth and yield modeling, we are putting to use spatial analysis, model builder, and Python. Then you have timber volume and carbon stock estimation. We're using the forest metrics, volume calculations, among other capabilities. On your screen are some of the tree species that are in Kachung Forest, which is located in Dokol District, Northern Uganda. We have Pinus caribera, we have Pinus enchinata, Pinus ariot, we have Eucalyptus aurora, and many other species within. On your screen is a map of Kachung with the different forest blocks. As we can see, the shades of green show the different forest blocks, the different tree species glowing within a particular block. As you can see, we have the light green being a Pinus enchinata. We have the lemon green, a case in point. This is giving us Eucalyptus ulophera. So the forest is not limited to only trees. We have other aspects that are on. Boreholes have been captured. There is a reservation area. for the National Forest Authority of Uganda. Then we have a community area that is being utilized by the community, the one in Cream, utilized by the community to plant trees. And these people can be outgrowers just in case the trees are ready to harvest and they are going to be used for timber logging or poles. We have a wetland, and then you have a conservation area. For these trees are meant to be continuously within that area. They are not being put to use. Otherwise, they can only be utilized if they have damage or they have reached their lifespan extent. Uh, to capture some of the capabilities of ArcGIS, on your screen is a ArcGIS Survey 123 form that will be filled by the field team, capturing data about particular trees within the forest. Like you have to capture the forest name, which block does the tree belong, at what time are you observing, who is observing, what tree species have you observed, what's the exact location of this particular tree. You get to measure the diameter at breast height. As I told you, this is an input for biomass, carbon stock, and volume. We also capture the tree height. You have the crown condition, among other aspects, not forgetting the tree health. Because this, we have an interactive platform, as this data is continuously being shared when you submit the form. The results are updated as may need be. So on your screen is an interactive dashboard. For the interactive dashboard, we have a map midway. Then we have an pie chart. This pie chart showcases us of what percentage of the forest is Pinus caribea, of what percentage is eucalyptus, of what percentage is echinata, and what area is still available, open area, which is what area is still available to be utilized for tree planting. As we all know, for tree harvesting or getting any other products from trees, raw materials, these are harvested at different times. So I have a bar graph showing the average age of tree species for the different for each tree species. We know that I'm capturing the average age so that you know that within this particular time we can at least be able to harvest or get a particular product from eucalyptus or pine. So we also have the area coverage, getting to know how big or what area is covered by eucalyptus calamadensis, then eucalyptus orifera. As you can see on the screen, we have Pinus and caribrea covering the biggest part of 124 hectares. So in case the open area is also utilized, information will be updated and still the coverage is still be updated. Still to go on, we have a table showing the biomass and carbon stock for each of the trees. So knowing that biomass and carbon stock are a basis of the diameter at breast height of trees, we capture the breast height of each tree in a block. So whenever these results are submitted, these will continuously be updated. Taking a sample space to check what details are available for each block. So you get to know what area is covered, when was it planted, how old are the trees in that particular block, what is their average diameter at breast height, what biomass are they producing, what carbon stock are they contributing. This carbon stock is often graded when it comes to carbon credits, as will be discussed further. So, okay. So that's the dashboard. So what to explore, getting to know that, we need to assess the health of the products we are having. Putting to use the normalized difference index, vegetation indices as one of still the capabilities of ArcGIS. We get to understand that over time, vegetation is affected by different aspects. This could be pests and diseases, could be fire outbreak, could be high temperatures or drought. So on our screen, taking a sample space of this block and the areas surrounding, we can see that in 2015, the block was very greener. Green implying the health of vegetation. Health of vegetation is represented by green. Yellow is the medium, not so good, not so bad. And then where I see the red pixels, those are the stressed vegetation or bare grounds. So over time, as we can see, the remote sensing image that was used for 2024 was taken within a dry season. So that could still be an impact of why you have more red, because we know we always lose canopy, leaves are shed off, and then we can get more rays from the bare ground to reflect. On your screen are two videos of eucalyptus and pine. These are just to showcase the benefits of eucalyptus and pine. So as we can see, we have a number of benefits, among which are the antimicrobial, bio, health benefits. These include the antibacterial and antifungal, antifungals that are within the oils produced using the eucalyptus and pine trees. Also still, we all acknowledge that eucalyptus is good for respiratory support. We've seen eucalyptus being put to use in the production of cough syrups. Still, the scents and omen produced by these two types of trees are good for relaxation. That scent is good for relaxation and it's often being utilized to that aspect. To go on, I would dive into the benefits of putting up GIS capabilities in forest inventory management. The use of the capabilities help us increase on commercial returns alongside conservation and sustainable development outcomes at a large scale to the stakeholders within the forest. Then there is timely and guided environmental, social, and governance decisions. Then the capabilities also help us monitor and assess the status of forest resources for timely harvesting and health status, as I've previously discussed. It's also easier to track forest assets, environmental compliance through carbon stock, and then the associated activities, thereby effectively managing costs and communicate where need be. It's also easier to understand the complex forest ecosystems and relationships, making it easier to monitor and evaluate forest inventory practices that are being undertaken by forest stakeholders for a particular forest resource. Thanks for your attention. Let's together plant more trees. We equally share the impacts of climate change. At this juncture, I want to welcome any questions. Thank you for listening to me. I'll take this opportunity to invite Nicholas to take on the podium.
Okay, thank you, Hadija. Hello to everyone joining this call. My name is Nicholas Kehato, and I'll share my screen with you. Yes, so as I had said, I'm Nicholas Kehato from Kenya. My project was on transforming electricity outage management through leveraging ArcGIS for smart outage management. As I move forward, I'm a graduate from the Technical University of Kenya with a bachelor's degree in urban design and development. And my experience in ESRI Eastern Africa has been really nice and enlightening. I've gained hands-on experience in ArcGIS, data integration, as well as developing interactive dashboards. I'm a curious explorer and someone who loves diving into new ideas and challenges. Also, my focus and career goal is on creating smart, efficient, and sustainable solutions for urban environments. So as I had said before, my topic was on transforming electricity outage management. So I have an overview and problem statement. The topic mostly deals with electric utility companies, which are organizations that generate, transmit, and distribute power. From the illustration diagram, you're able to visualize some of the challenges that electric utility companies face in managing outages, responding to faults, and keeping customers informed. Most of the companies use traditional management systems, which rely mostly on manual reporting, delayed fault detection, and inefficient communication. This leads to longer downtime, frustrated customers, and operational inefficiencies. So with advancements in GIS automation and predictive analytics, electricity utilities can now implement smart outage management systems, which will provide real-time fault detection, automated response mechanisms, and seamless customer communication. So as I move forward, I have my solution, which entails an intelligent and smart electricity outage management system. It's a GIS-driven solution that integrates the systems of systems approach. This entails the system of record through mapping and data management. The system of record will dwell on mapping the power grid, tracking power outages, and managing the assets. Then to further explain it, the system of record will be feeding data into the system of engagement for decision making, design and planning, as well as sharing and collaboration through communication with the customers. Then this is then optimized through the system of insights, through analytics, monitoring, and field mobility to assist in the asset management. So I developed objectives and benefits to assist me in attaining my solution. So the objectives were automate response times, provide customers with accurate and timely outage updates, optimize resource deployment, streamline outage management processes, use predictive analytics to identify fault zones and prevent outages. So for the benefits, we had proactive management of outages, improved grid reliability and quicker restoration times, faster fault detection and isolation, increased customer satisfaction, and enhanced operational efficiency with automated systems. So moving forward, you can see the solution architecture. The system relies on various data inputs to detect outages and predict failure, as well as optimize outage management. From down below, you can see some of the data sources that will be relying on. This includes the data collected from fields, the social media and online data, also power infrastructure data from transmission and distribution. We also have the weather patterns, as well as also GIS data in terms of the raster layers and the vector layers and shape files. Then all this data is collected and it flows into a GIS system, which will act as the central platform for processing and analysis, as well as decision making. The, the central platform itself is connected to cloud-hosted GIS servers, as well as and online and server infrastructure that will be used to integrate it with the existing database and business systems for the utility companies. It will also be interfaced with the enterprise resource planning for the electric utility companies, for the field teams. And then this data through the desktops and apps and also phones will enhance user access to the various users. You can see on top, we have the customers, We report outages, receive updates. We also have professional GIS users that will analyze the data, perform predictive analytics, generate spatial reports. We also have the control center operators that will monitor the grid, dispatch the repair teams, and also make decisions about the fault isolation. There will also be the executives as well as stakeholders who enhance planning, policy, administration, as well as the communication. So moving on forward to the next slide, we have the data integration and processing. So seamless data integration and processing is very critical for outage detection, response, as well as prevention. This process, as we'll move forward, we'll see it will involve data collection from various sources, and this data will be merged into the centralized system I had mentioned before. And it will entail the cleaning, also transformation, analysis, as well as the data management of the data itself, so that it's finally visualized in dashboards, allowing stakeholders to monitor the outage, predict potential failures, and deploy proactive solutions. So we have the data sources we'll be focusing on for the solution. We have data on the electric utility network. This will deal with the substation, the distribution transformers, as well as the transmission lines, all the way to the poles and to the customer meters. We'll also be using the field data collected on site. We also have outage data, the customer information data. We also have data on climate as well as weather patterns, and also the online data. So as we continue, so firstly, in data, so that we may receive data on the outages, I developed a USSD integration into the system to enhance customer reporting. This USSD system will allow customers to report power outages and also check on their outage status using a USSD code, like let's say maybe 123. Then this will be through their mobile phones. So the USSD gateway sends user inputs to the Flask app, which will be like the server hosting the data. Then after that, the Flask app will process the request, and it is then integrated with an ArcGIS feature service through the REST API, so as to store the data. So as I move downwards on the code block, you can see it has a menu for two responses that a customer will be choosing among. So for one, he or she may report the power outage. For two, if he or she is checking on the outage status. So let's say the customer keyed in the first option, which is to report on the power outage. The system will inquire for his or her meter number. Once the meter number is sent, the system sends this information into the ArcGIS database, and is with the ArcGIS database, which stores the outage report. Then the customer will get a notification that his or her outage report has been received and will be updated soon. If then the customer chooses the second option, which is to check the status, the system also will ask for the meter number, and then it searches the ArcGIS database for that meter number, and the customer will get also a message in two ways. Let's say maybe the meter in inquiry did not report any outages, and also there's also another message he or she may receive that's maybe the power is under restoration. So as I continue, I also integrated another form that customers may use to report on the power outages using the survey 123 form. This is a very good way to report, since community members can share it among their WhatsApp maybe groups, so that maybe they may feel the information. You can see here, they sent the customer name, phone number, status, is it a power outage? Then you key in the date, also the start time. You can also gauge the severity of your situation. Is it high, low? You can add a comment, also an email. And then you are also able to pinpoint your location so that once the report is received, we can know where the case is reported from. So as I continue, I will delve into the field operations system. This will enhance connecting the customers to the call centers and then to the field dispatch teams that resolve the power issue. So on this far end, you can see the workflow of the operation. We have the customer reporting the outages. Then the outage report is then processed to the call centers, who then as the call centers are able to dispatch technicians to the field. And then the technicians on the end are able to navigate to the field and solve and repair the issues. So you can see from here some of the capabilities ArcGIS as an enterprise has to plan and coordinate. It also captures, creates awareness. On the find, you'll see the various products I'll be incorporating. This is the survey 1, 2, 3 form as I had shown you for the customer reporting. Then will then be visualized using the operations dashboard by the call center operators who then use the workforce to dispatch the field teams. The field technicians deploy navigator as well as collector for GIS and field maps so they are able to navigate through the field. So as I move forward, I will now be showing you some demonstrations of the ArcGIS workforce, the field maps, as well as some of the dashboards. So firstly, we have the ArcGIS workforce for the call center operators. You can see I was using my case study for Kenya Power, which is a utility company in Kenya. So this is what the operators will be using to dispatch the field agents. So you can see it's a well integrated system that can also be used for other assignments by the electric utility companies. You can use it for, let's say, outage data, if it's a repair transformer, if it's to replace fault meter, if it's to reset a circuit breaker. You can use it for various roles. Let me show you how we create assignments using the application as it loads. So you're able to see the interface that the call center operators will be using. Over here, you can see we have two types of points. We have the red ones and the yellow ones. The red ones represent the active outage sites. So if I'm about to, and we also have data on workers with this symbology of cars. So if I want to send out an assignment, okay. If I would like to create an assignment, I am able to do so. I can pick from the assignments here, which type of assignment I want to put across to the field workers. Is it maybe an outage, a fixed downline, an emergency power restoration? I can do that. I can also assign to look for one of the workers who is on site, send the priority, and I'm also able to track if he or she is on work. So as I move forward, I'll show you another demonstration for once now the work has been dispatched to the field technician. Now through the field maps, you can see now how the technician will be able to navigate through the site to the location of the outage report. So as it loads, able to see this is also their interface. I have worker data, as I had said. If I can key into my first worker. Yes, this is a technician called David Kim. You can see the status is on break. And let's say, since I can note David Kim is around that area, around this area. So most of the outage reports I'll send his way are the ones that are near his location. And maybe he wants to see, maybe you can also highlight to see the directions and let it load. And maybe I want to send him to this location. Yes, so the field technician is able to, through route navigation, he or she can see the quickest route to that outage location. And it also calculates the minute time that he or she will take to that area. So moving forward, I have a workforce management dashboard as it loads. This dashboard will be providing insights into the workforce deployment, the resource allocation, as well as performance metrics that will be used by the electric utility companies to see how the workers are working on site. So you're able to see our total workers are 5. These are the outage reports. I had classified them with the red ones taking the upper position because they are the highly critical ones. We have our workers. You're able to check their status if they are available, if the worker is on break, if the worker is on en route, and if the worker is on site. So you're able to visualize and see how they are working and what they are doing. I also integrated data on substations. This data is really important since by use of the transmission lines, you're able to see which substation is facing which, it serves which line. And with that information, you're able to assess where and which lines are out of power. So moving forward, finally, to my last dashboard, this will be an operations dashboard that will be used to enhance situational and also monitor the outage data, also check the power infrastructure data as it is. So if you can check it over here, we have a lot of layers incorporated in this dashboard. If I can move to the distribution transformers, as it loads, you can see we have this now RCC. It means the regional call centers. You're able to see, as I had said, because I'm using my study area as Nairobi, we have the regional call center for Nairobi North. So you can also see some of the key attributes you have in your layers. This data is really important as the utility companies can be able to manage their assets. You're able to see this distribution transformer, the type it is, it's a wooden structure. You can also see other informations, the feeder. You can see if it's an outdoor. You can see if it's an outdoor. Yeah. So as I continue, by visualizing the map, you can see where most cases of outages have been reported. These are the areas with the yellow color. These are where most cases have been reported for the outages. And also you can visualize and see the reported customer outages are 200. On this far end, we have charts and graphs that show the count by severity. We have the active cases, also the resolved cases that are critical, high, low, and also medium. And also check out the count of costs of the outage. We also have the outage type. Is it a complete outage? Is it a partial outage? Is it a voltage fluctuation? And also the system allows you to query. So if I would like to query, I can show on the map and you're able to see my points. if I would like to see the points in the table, I had queried with regards to where the outage is active and outage severity is critical. These critical are the areas that are of critical infrastructure, like the hospitals, which need a lot of attention. And in case someone may need the report, I can export it, able to export the report through CSV and also as a shapefile if you would like to do so. So that will be all for my presentation. I'm open to any questions the audience may have. And as I finalize, I would like to invite my fellow colleague, her name is Juliet, to take over.
Thank you, Nicholas. I'll now share my screen. Good morning, good afternoon, good evening, everyone. My name is Chepkemoi Juliet, and I'm honored to be here today. I am a geospatial technology specialist passionate about GIS-based logistics, spatial analysis, and real-time monitoring, with a Bachelor of Technology in Geoinformation Technology from the Technical University of Kenya. This experience has been incredibly rewarding, allowing me to deepen my knowledge of GIS and its practical application in solving real-world challenges. Beyond geospatial technology, I enjoy hiking through scenic landscape. I'm happy to share my journey and insights with you today. My project is on liquefied petroleum gas management system using ArcGIS. This is a GIS-driven approach to efficient liquefied petroleum gas supply chain management. I'll now share my screen on my solution ecosystem. I'll first introduce about my project, enhancing liquefied petroleum gas distribution with GIS. Energy regulatory authorities in Eastern Africa ensure efficient, safe, sustainable energy distribution. They regulate traffic, issue licensing, enforce safety standards, and promote clean energy adoption. In Kenya, the Energy and Petroleum Regulatory Authority, known as EPRA, oversees the energy sector, ensuring compliance and market stability. Under EPRA, which is the Energy and Petroleum Regulatory Authority, the State Department of Petroleum, known as SDP, drives policy to expand the liquefied petroleum gas adoption, especially in schools. Private sector players, including the marketing oil companies and retailers, manage the supply chain from importation to distribution. This project leverages GIS technology to enhance gas distribution, ensuring schools receive a steady and efficient supply while improving logistics and decision making. I'll now dive into my liquefied petroleum gas solution ecosystem. At the center is my liquefied petroleum gas solution system, and on my left is the government sector, and on my right is the private sector. On the government sector, we'll start with the head, which is the Energy and Petroleum Regulatory Authority. It regulates the gas industry, it regulates the petroleum and gas industry, ensuring safety and efficiency across upstream, midstream, and downstream supply chain. While the State Department of Petroleum is implementing the gas use in school, it's enrolling this school's program. On my right, we have the marketing oil companies, which is the private sector, which manages bulk gas distribution and has private distributors such as Total Engines and Shell, which distributes the gas to retailers that serves the different schools and other businesses. And here down we have the private distributors and the refill stations. They handle sales and small scale distributions, while here the business and the customers, these are the schools, the hotels, or other industries that use the gas. This system is mobile, hence expansion. There's expansion potential for petroleum and gas industries for Eastern Africa. I'll now dive into my next slide. This is my liquefied petroleum gas distribution framework, my system of systems management. This starts at the depot. It uses ArcGIS for mapping depot routes and consumption areas, while the system of engagement, that is planning and sharing, uses the workforce to ensure smooth coordination between the depot, the transport, and the schools. This is the liquefied petroleum gas distribution track. And then we have the system of insights. This is the analytics and monitoring. It provides dashboards and reports for informed decision making. I'll now go to my next slide, which shows the general outlook of my project. This is just a sneak peek into the core elements of my LPG distribution system. Stick with me as we break down each part, showing how GIS transforms distribution, enhancing efficiency, and ensures every school gets the gas it needs. It will include identifying the gas demand, the route optimization and depot capacity, the LPG deliveries and monitoring the supply chain, safety and monitoring, emergency responses, and stakeholder engagement. Now I'll move to my next slide, which is my solution architecture. This is an enterprise GIS system that integrates the Internet of Things for real-time monitoring and spatial analytics to support large-scale gas distribution. I'll talk about every layer, stating its purpose and function. I'll start with the sensor layer. It captures real-time data from the liquefied petroleum gas tanks using the Internet of Things enabled sensors. Its function is to monitor the gas levels in the storage tanks. I go to my next, which is the communication layer. Its purpose is to ensure seamless data transfer between the gas trunks, GIS databases, and users. It uses cellular network, that is the 4G and 5G, the satellite network for remote areas, and the Internet of Things for real-time monitoring. Is secure data transmission to a centralized user, the centralized server. This is the centralized server, and I'm going to talk about it. Its purpose is to store and organize data collected from the liquefied petroleum gas sensors. It enhances security and integrity, allows authorized users to access real-time information, hence it's secure. And then I'll go to my analytics layer. Okay, analytics layer, its purpose is it uses ArcGIS tools to analyze and visualize the gas distribution trends. Then there is data integration and visualization. The purpose is to integrate GIS data with real-time gas monitoring for decision making. Here, the executives can access was hence supports the policy and control and planning. They oversee the whole process. And then on my left corner, we have the stakeholder engagement and support. The purpose is to enhance coordination between the gas suppliers, school, and the government agency. Function is just to ensure smooth information flow between stakeholders. I'll dive into my next slide. I'm working on that. Oh, sorry about that. Let me reshare my screen. Hello everyone, sorry about that, but it's now sorted. So I'm going to go to my next slide, which is depot and supply chain management. This is LPG, depots, and the distribution process. Each depot is linked to assigned schools with real-time consumption tracking. This system integrates depot storage levels, school refill needs, and optimize route planning to enhance efficiency and ensure a continuous supply. This then ensures this is regulated by the Energy and Petroleum Regulatory Authority to enforce safety, compliance, and industry standards, managed by the State Department of Petroleum, which is driving this gas adoption in schools, and then executed by the marketing oil companies and retailers to supply the gas efficiently. Challenges addressed are inefficient deliveries, supply shortages, and risk for unauthorized diversions. The solution implemented the GIS dashboards for real-time monitoring and automated alerts for lost stocks and refills. I'll dive into my next slide. Oh, no, this is a survey 123 form that will be filled by the different schools. It will be distributed by the State Department of Petroleum to the different schools in the country. The schools will have to fill in the school name, its location, the school population, the school category, the primary cooking method, the gas status, and then the LPG consumption in average for a month. Now dive into my next slide, which is route optimization and school optimization and route and school deliveries, optimizing delivery routes with GIS. Using ArcGIS Pro LPG, the liquefied petroleum gas delivery routes are optimized for timely deliveries with drivers assigned based on depot capacity and school demand. GIS helps in smart route planning, balanced workload, optimized routes, provide spatial insights for emergency supply reallocation in case of shortages. This will have backup depots that the schools can access and receive gas during such emergencies. Now dive into my next slide. Oh, having trouble here. Here it is. I'm now going to share my next slide. This is ensuring continuous liquefied petroleum gas supply. This is real-time monitoring and refill alerts. This GIS workforce dashboard that I am going to show you shortly enhances the liquefied petroleum gas supply by providing real-time depot stock tracking, automated refill alerts, and emergency refill systems. Here I have my workforce. This is the liquefied petroleum gas driver workforce management. This will be used by the dispatchers, that are the distributors of this gas to the different schools. They'll assign work to the different drivers. Let me show you how drivers can be assigned tasks. Then you go to the driver vehicle assignment data, and then you create assignment. You assign type, you pick a type of assignment that you want to assign, the location, then assigned to which driver, then you show the priority, the ID, and the description of the emergency, of that emergency assignment. Then you can send it. Now I'll share my dashboard. This is the LPG driver delivery management dashboard. Here, this dashboard provides real-time monitoring of the gas distribution operations, driver assignments, and the depot stock levels. I'll describe the purpose of each layer. I'll start with the driver performance. Here, the trucks. Here, we track the number of tasks completed by the drivers. Then we have the depots, the different depots. This is a gauge that shows the level of the stock in each depot, which I have 5 depots. Then we have the driver availability, which displays the percentage of available, busy, or on leave drivers. Here at the center, we have the dispatcher map, which visualizes driver location and the gas deliveries in progress. This is done in real time, can be visualized in real time. And then here we have the live driver assignments. It's a list of schools currently receiving the gas. And then the red X indicates schools with pending deliveries. And we have the map legend, which explains driver status, the LPG storage conditions, shows routes and their workers, their assignments. I'll now go to my next slide. This is a dashboard for decision making. This is a data-driven insight for the liquefied petroleum gas distribution. I'll first tell you the benefits of this. It ensures real-time data access, supply chain optimization, automated refill status, the policy and strategic planning. This is the main dashboard that includes all that we have discussed, and I'm going to explain each. This ArcGIS online dashboard empowers stakeholders. This includes the government, the MOCs, which is the MOCs who are the marketing oil companies, and then we have the retailers with real-time insights into the gas distribution. And then on the slide, I'll explain what each part's function. I'll start with delivery time per driver. It shows the average time drivers take to complete deliveries. We have the schools needing refill. It displays the number of schools requiring the gas replenishment. And we have this pop-up. It filters each depot, so you can access, you can get information for each depot that you want to. It has the depot A, depot B, C, D, E, and it highlights the depot capacity, the demand count, the operation status. We have the delivery status update. It tracks the number of deliveries at the depot and delayed shipments. This is an interactive dashboard. You can click on it and see that drivers delayed, en route, completed tasks, and so on. Now I'll discuss the LPG consumption. This is the average and the total usage across the school. The purpose of this dashboard is to help optimize the gas distribution, track depot stock, and ensures timely school refills. Now go to my next slide. These are benefits of GIS in the gas distribution, transforming the liquefied petroleum gas supply with GIS. The benefits are to optimize supply chain management, increase business efficiency, enhance transparency and accountability, data-driven decision-making, energy security and sustainability, cost reduction, and route efficiency, and rapid emergency responses. Wales can build a sustainable, efficient, and transparent liquefied petroleum gas distribution network across the countries. In this case, it's Kenya, but it can be used in all the Eastern African countries. Here we have transforming schools, ensuring clean cooking in schools. The liquefied petroleum gas enables clean, efficient, and reliable cooking in schools, improving kitchen operations and meal operations. It's a safer alternative from firewood and charcoal. It's eco-friendly energy solution and cost-effective and sustainable. By transforming to liquefied petroleum gas, schools create healthier learning environments while promoting sustainable energy use. Well-fed students perform better in class and sports. And that's true. You can see. I'll take any questions that you may have on the chat side. That's the end of my presentation. Thank you. I'll now invite my colleague Sarah Wangari to share her journey. Thank you.
Good morning, everyone. My name is Sarah Mirori, and I am here to present a project on an open roads data portal. Let me share my screen. So, first of all, an open roads data portal project, which will be aimed at transforming road infrastructure management using ArcGIS systems. Just a minute. So first of all, my profile is that I have a background in geomatic engineering and GIS, and I believe that data is powerful. And with this, visualization is what makes it worthwhile. As a Quarter 1 intern at Esri Eastern Africa, I have had the privilege to learn about Geo AI and integrate it in ArcGIS systems, specifically to ensure smooth road asset management and intelligent traffic monitoring. So an introduction to this project is that I am supposed to create an open roads data portal, which is a portal for roads data that is a public facing platform. It serves as a central hub for road inventory, condition management, and providing traffic data monitoring. So at the end of this, you'll be able to understand why road infrastructure management is crucial for road agencies and also for the public. Some of these include duplicated efforts by the different road agencies, poor data management from traffic surveillance cameras, and data flow breaks between the managing roads authority and road agencies. My solution aims at curbing all these three challenges. The current road infrastructure management cycle shows us that first they plan, allocate budgets, collect data, prioritize and select the project, design and procurement, execute, monitoring, and then asset management. So these 8 steps tend to be very recurring for each road agency. And as a result, especially the data collection aspect, these road agencies have siloed data. Each road agency has their own data, and this creates data flow breaks between data management. So I aim at creating a centralized road data management center. That's the hub, the portal, providing interactive roadmaps that feature road network data, road asset management, and road surface type data. Aside from that, we have inventory tracking. This enables us to provide inventory tracking and planning and budget allocation for road projects. So this is my solution architecture, whereby from the database that contains this four data sets, sorry, you get to the portal, and the portal acts as a hub for intelligent traffic monitoring, road network, road assets inventory, road condition, and road condition monitoring. This allows executives to make decisions on road infrastructure management, provides also education and awareness to the public on road network and road assets and road conditions, and professional GIS users are able to query the database, retrieve records of road network, and assess road conditions. A section that I have mentioned is an intelligent traffic monitoring system using ArcGIS, whereby we will be leveraging IoT and AI to monitor traffic in urban areas. This is my solution architecture for the solution. We have traffic feeds, motion feeds from surveillance cameras placed at different intersections in Nairobi County. Some are placed at the Nairobi Western Ring Road, Ngong Road, Mbagathi Way, if you've seen them, Ring Road, Kilimani, Kileleshwa, Riverside Drive, etc. So these feeds act as the Internet of Things, and they are fed into an deep learning model, which uses artificial intelligence to provide counts of data to detect the object and provide counts of data, which are then fed to the server managed by the Intelligent Traffic Safety Department at Kenya Urban Roads Authority. And this is fed into a dashboard that gives analytics and helps us to make decisions on traffic monitoring. So this is largely managed by the Intelligent Traffic Safety Management Center at the Kenya Urban Roads Authority. It allows us to have operations intelligence and eventually a digital transformation, since we are heading to a digital world. So this is just a snippet of the model training aspect, and I am going to play a video. This is on the left, we have an input video. On the right, the output, that is after going through model training. On the right, as you can see, there are rectangles around each vehicle or each objects within the field of view. Those are bounding boxes that are generated by the model. As you can see here, the second video is some 5 seconds behind, but this is how we use GeoAI for ArcGIS systems using trained and pre-trained models for smarter decision making and efficiency. Next slide. So I'm going to head on to my demo of an open roads data portal. Oh, damn it. Just a minute. Let me share my screen again. And sharing. Okay, so I hope that on your end you can see that this is an open roads data portal that acts as a central hub for road network data, road surface type data, and road asset management data, and an additional intelligent traffic monitoring data. So the first aspect of this road network, of this portal, is a road network hub. This is an interactive web map of all road class data in Kenya. This includes national trunk roads, that is class S, class A, class B, and class C. And there are minor urban roads, AU, BU, CU. Aside from that, we have county roads. Those are class D, E, and other feeder roads. So from this, if you are the public, you get to see the road network and interact with this data. For example, that is Gatito Muroka Road in Murang'a County, Central Region, Class G. If you are the road agency, you get, the road agency is mandated to, this portal has role-based access whereby the road agency is able to organization as well as export this data. There's an export function. For example, if a specific road agency requires roads for, let's say, Baringo County, they can filter the roads based on counties or based on field ID, based on the surface, based on the road names, road classes, etc., etc. So that is for Baringo County. And zoom out, you see, that is only roads for Baringo County. Moving on, the road surface type indicates the condition of the road surface type, that is whether good, fair, or poor. Good, fair, good, poor, or under construction, sorry. So as once again, as a public facing platform, you, the public, can be able to view this data and interact with it, while the road agencies can be able to update this data. For example, this data was collected in 2019. So if the road agencies require to update this data, they can do that on this portal. Road asset management provides data for all road assets in Kenya, including pipe culverts, bridges, box culverts, drifts, main probes. Okay, so this is mainly for engineers, and yeah, some of this information is for them. And finally, I am going to jump into the intelligent traffic monitoring dashboard. And traffic monitoring dashboard. So first of all, we left where there is a video of cars with bounding boxes. They are then counted, and from there it acts as a live data stream towards this dashboard. If I play the dashboard, you will get to see the different counts at different intersections are all around Nairobi County. The counts are written over here, 9 to 10, or the smallest are less than 2 cars. So that is a time period of between 9:50 and 10:10, according to the traffic motion feed that I had. Aside from that, you also have the analytics platform on the side. We have a bar chart that will show you time counts at specific times. So probably at 10:05, the counts of cars were 5, and they were around Mlango, this intersection. This is Mlango Kubwa. Against Muratina Street, etc., etc. So this will enable the Intelligent Traffic Safety Department to understand how traffic moves for each intersection in Nairobi County as per the pilot phase of the traffic monitoring project. Aside from that, we have traffic alerts. These are alerts that have been set for this live stream as data flows into the dashboard. If you have set an action of, let's say, more than 10 cars are at the intersection at one specific time, it provides alerts to the department. So this enables the department to understand if there is an issue. For scalability purposes, in future, we can be able to control traffic signals based on congestion. And my time is up, so in case of any questions, I will be able to answer them after this. But for now, I would like to hand over to my colleague Albert to continue. Thank you for your time.
Thank you, Sarah. Allow me to share my screen. My name is Albert Moreidi. Today I'll be presenting stormwater drainage management system. This is a GIS-based system designed to monitor and manage drainage and sewer infrastructure using ArcGIS tools. Before we dive into details, allow me to talk about myself. I'm a computer science student at the Cooperative University of Kenya. I recently discovered GIS and spatial data, realizing that maps do more than navigate. They tell stories and solve real-world problems. Through my internship, I've gained hands-on experience in GIS, mapping, spatial analysis, and real-time data management. Learning how to collect, analyze, and visualize spatial data effectively, combining my passion for technology, coding, and automation with GIS, I see endless possibilities in developing smart data-driven solutions that optimize processes, improve decision-making, and drive innovation in geospatial technology. To fully understand why this system is needed, let's examine some challenges cities may face. Urban areas face frequent drainage failures due to blocked stormwater channels, damaged sewer lines, and inadequate capacity. The lack of real-time monitoring delays maintenance, leading to costly damage. This leads to clogged drains and sewer overflows, posing public health risk and disrupt daily life. To address these challenges, the system utilizes ArcGIS capability to enhance monitoring, streamlining reporting, and improving the efficiency of the sewer and drainage maintenance. By integrating community reports, field using ArcGIS Survey 123, field inspection using ArcGIS field maps, and workforce task assignment using ArcGIS workforce. The system ensures a data-driven approach to resolving drainage issues. The system follows a structured flow. It involves the first step is monitoring, where public report through survey 123. And since we cannot rely just on that, we have scheduled field inspection, which is done using ArcGIS field maps. The system having collected public reports data and inspection data, the system processes the incoming, and this data triggers task assignments for maintenance and repairs. All this data for public reports, inspection, task assignment is visualized through dashboards to allow executives and city planners to make decisions. I'll take you to the system solution architecture. It aligns with the system flow by demonstrating data collection, analysis, integration, user access, and decision making. Data is collected from survey forms, field maps, and also the workforce. It has a centralized database, and it's accessible through mobile devices from the web, desktop. It has various users, the public administrators and external collaborators. I'll take you through a quick demo of the system in place. The first step is monitoring, and since drainage problems can be reported by both public and inspections, we use two approaches. The first approach is a member of the public identify an issue. He will open the survey form, specify the date, the urgency of the problem, specify whether it's a stormwater problem or sewer problem, give more details whether it's blockage, overflow, or break. You can add description of the problem, attach an email, specify the time and attach a photo or a video, and specify the location. And the other approach is the field inspection. A field inspector will now open, a field inspector will conduct a routine check to the existing drainage and sewer network, and will update the condition, and it will update the map. Now at this step, we now have reports from survey 1, 2, 3 and field inspections. Now with this data, the system is ready for the next step, which is assignment and repairs. As a supervisor, I open the ArcGIS workforce. These are survey points. I'll click on a point, and I can create an assignment based on that. Can create an assignment and assign a worker. I can search for a poor sewer line or stormwater channel. Now you can see the results. I can click on, with one click, I can create assignment based on that and assign a worker. Now the worker will go to the field, and once they are done, they can update the condition. You can see here, these are completed tasks, and these are declined tasks, and various assigned tasks. Now from here, all this data is visualized in ArcGIS dashboards. These are repair and maintenance tracking dashboard. Decision makers can see, supervisor can see the number of assignments, the workers and their status, and attached contact number. They can see whether that task is completed, due date, priority, and the location. An example is this task is completed, and you can see the location is based on a survey, point. Another one is a sewer line. And another one is a stormwater channel. Here we have a chart which allows one to download and can share this data to various stakeholders. Now we'll go to the public reports dashboard. This dashboard allows the decision makers to track daily reports. I'll select a date. Now you can see these are the total reported cases. One was a stormwater report and sewer line report. And you can see the details here. It gives further details here, whether it's the urgency, the specific issue, and type of the issue. This is now the chart, which allows one to download the data and share. Now I'll go to the final dashboard, which is the inspection dashboard. Here, the executive and decision maker can see the inspected stormwater channels, same case to the inspected sewer lines. They can see how many channels are poor, fair, or good, same case to the sewer line. But also this data is available for download. Here you can see the materials and their status, which now here they can determine which materials are the most affected, and same case to stormwater, you can see. Now that's with this approach, we move away from reactive maintenance and toward the data-driven approach, preventive strategy, ensuring a more resilient and well-maintained drainage system. In future, with the enhancement in technology, we can integrate IoT sensors to provide a real-time flood and blockage detection, apply AI to predict high-risk areas, and also integrate USSD codes to capture as many people as possible. That's mark the end of my presentation. I'll now invite Marcy to present.
Thank you, Albert, for that. Allow me to share my screen. My name is Marcy Ndani Mungata, and my project was on a carbon credit project management system, which is a centralized solution for carbon credit project tracking and verification. So a little bit about me. I'm a recent geospatial engineering graduate from the University of Nairobi and a current Q1 intern at Esri Eastern Africa, which has been both a fulfilling experience and eye-opening. With the skills I have gained from Esri, I aim to be the bridge between data and storytelling, where maps aren't just maps, they are narratives waiting to be told. When I joined, I initially thought ArcGIS was just about maps and spatial analysis, but I quickly realized it's a whole ecosystem of powerful geospatial solutions, from real-time data management and remote sensing to AI-driven analytics and workflow automation. I've gained hands-on experience in how the ArcGIS system transforms decision-making across very many industries. So just an introduction to this project. Kenya's carbon market is evolving, with NEMA playing a key role in regulating carbon credits and ensuring compliance with both our national and international climate policies. The market requires a centralized, as of now, it lacks a centralized data management system to track and verify carbon credit projects efficiently. The system relies on private brokers and international verification bodies, hence leading to double counting of credits, reducing credibility. There's also limited transparency, making it very difficult for stakeholders, for example, investors, to access reliable data. There's also challenges in monitoring actual carbon sequestration, especially in biological types of sequestration due to a lack of integrated remote sensing workflows. We also have missed opportunities in ITMOs, which are international carbon trading agreements. This is because of the inefficient tracking mechanisms of the carbon credits. And we also have limited knowledge on carbon credits. I know most of us here maybe I've had this once in a while or here and there, but they really don't know much about it. So the proposed solution is a centralized system leveraging ArcGIS for efficient carbon credit project management. It also integrates remote sensing workflows for accurate emissions tracking and reduction monitoring of nature-based solution. This system will also enhance Kenya's ability to manage carbon sequestration effectively to prevent, hence preventing fraud in carbon markets and supporting its commitment under Article 6 and the Paris Agreement. So just a bit of a background, this comes as a result of the Climate Change Amendment Act that was set in September 2023, and it constituted a national carbon registry and regulations for carbon projects and trading. The Amendment Act specifically strengthens NEMA's mandate in overseeing carbon credits projects, ensuring compliance and preventing exploitation. And this is why this specific project will target NEMA, but can be used by any other environmental agency across many countries. So the main objective is to develop a centralized carbon credit project database for Kenya, ensuring real-time transparency and investor confidence. The supporting objectives include using remote sensing workflows to track and verify nature-based sequestration. We also wanted to provide an interactive web portal for querying and visualization, as well as streamline carbon credit projects approval via workflow automation, and to provide an information hub for people to access knowledge on carbon credits, as we shall see later on as I continue to introduce the solution. So just a bit about carbon credits. Carbon credits are tradable certificates or permits representing the right to emit 1 ton of CO2 into the atmosphere due to essential business activities. So in and of themselves, they are certificates circulating in the market, but they are generated from various projects. Their purpose is to incentivize businesses and organizations to reduce their carbon footprint. And we currently have 2 types of markets, compliance markets and voluntary markets. Compliance markets are government-related, while voluntary markets are self-regulated. Currently in Kenya, we are in a voluntary market, but we are heading towards a compliance market. So there are 2 types of carbon credits. We have avoidance and sequestration. Avoidance focus on preventing greenhouse gas emissions that would otherwise occur. A good example would be energy efficiency, like cook stoves, providing cook stoves or providing biogas to prevent emissions that would occur. And sequestration is a fancy word for removal. Sequestration projects focus on removing CO2 from the atmosphere and storing it into natural or artificial reservoirs. And examples of sequestration include biological, technological, and geological. So for the solution architecture, we have the NEMA Carbon Credit Project Management System designed as a centralized, secure, and scalable platform utilizing ArcGIS technologies to streamline carbon credit management, enhancing transparency, and supporting decision-making. So at the center, we have the centralized database that will ideally be based on ArcGIS Enterprise and SQL Server. It stores the verified carbon credit projects, ensuring data integrity and preventing double counting. We also have the ArcGIS Server, which manages geospatial data to enable real-time access and analysis. It also facilitates data sharing between the different stakeholders. At the back, feeding the server, we have the data preprocessing and geospatial analysis, as we shall see later on. We also have online content and services, and the image server used in the remote sensing workflows, as well as field data management coming from field collections. So feeding into the database, we have project submissions of new projects incoming through Survey 123, which will also be verified by the relevant teams. So to interact with the public and any other stakeholders or executives access, we have the ArcGIS portal, which has an interactive web map that helps visualize carbon credit projects across Kenya or the country that it's used in, with interactive tools for data filtering and exploration. So moving on swiftly, among the common patterns of use used in this project is mapping and visualization. We have data management, we have field mobility, spatial analytics, constituent engagement, sharing and collaboration, and decision support and workflow automation. We shall see later on. So the first solution is a website where people can come in. They can first submit a project, but before we go to that, I'd like us to interact with the rest. So you can monitor land cover across the different years using the Sentinel hub that has been that I hosted on here. If you want to understand, maybe you don't really know much about carbon credits, you can click on the Understanding Carbon Credits tab and interact with the story map that guides you through. Like, what are they? What are carbon credits? How do they work? You can see step by step what happens. You can see the types of different carbon credit projects, and this is information accessible to everyone. You also have the benefits. You can see the different benefits, also giving examples of the different type of projects and their benefits. And we can see Kenya's role in carbon markets, where we can share different how we have contributed to the international markets. Kenya is actually one of the leading stakeholders in the international carbon credit markets. You can also click on this tab to see how you can get involved as a project developer. This is to ensure that everyone can understand what happens and how they can partake in a project. This prevents exploitation. So if you go to the current projects tab, we have a dashboard with an interactive map as it loads, setting out all the different carbon credit projects happening in Kenya and their types. You can also interact with the map and see the different types of projects, even as the indicators in the dashboard keep on changing. So let's say, for example, you're interested in a specific project. Let me zoom out so that the different types can come into the pie chart. Let's say you want to click on one specific project, and for the technological type, I use dummy data as a disclaimer. Let me just share that beforehand. Yes, to zoom to the specific area of that project, and a pop-up will come up listing out all the different types of information of that project contained in the database that's accessible to the different type of user types. So for example, you want to interact with this project design document, you can click on view and it will actually take you to the PDF document hosted on there. And even the different types of documents, we have the feasibility study. So this is an example domain as it loads. okay, it's an example domain. I think I can go back because of time. You can also come and interact with the different registry dashboards. So currently we have two main international bodies giving the standards for carbon credits. We have the Vera registry and the Gold Carbon Standard Registry, which is called the GSF registry. So if I click onto it, I can actually interact, and this is a dashboard made on non-spatial data, and see the different types of things happening on there. So let's say, for example, I click on one, I can see the different indicators changing. I can also access the specific registry if I want to check other countries. So for the general Kenya itself, I have a carbon stock estimation that I did for years coming from 2000, 2005, all the way to 2025 in epochs of 5 years. So you can toggle on and off and interact with this data and see the different types of changes across. And this carbon stock estimation was done on MODIS and DVI. You can see the different types of data. And if you want to download or export this, you can actually do that. So let's say, for example, this is a legend to see the different values. And if you want to export, it will take you to the various channel for that, where you can export. Yes. Export data as a tile package. We also have a tab for the various projects. Even as that loads, I think I'll go to the next slide. Shall see this on the next slide. So for the automating workflows, we have ArcGIS Workflow Manager. An ArcGIS Workflow Manager is a scalable workflow management system that automates and simplifies many aspects of performing and managing GIS and non-GIS work. So let me just take you through the document. So this is for any new project submissions into the database. The first instance, once you remember the button I showed you before, when you click on that as an interested investor, it will take you to a survey 123 form. So once the survey form comes, it notifies the first individual in that instance. And this is the first person who is the admin. And then the admin will go and escalate this issue to the initial review team, who will have a form to just check and cross-check your documents. And then if that passes through, it goes to the technical review team. And then it goes to the GIS team and the field verification team. From then on, this goes to the verification decision team, who then decide yes or no, like, is your project to be updated in that website. This makes sure that, you know, this is authoritative data. It's not just people submitting data and that's it. So if you want to manage, you can manage your work and see all the jobs in this tab and access the different types of jobs and the activities that have been happening. As a manager, you can also view who's working on what and assign different tasks to different roles. You're also able to view the jobs themselves in different priority levels. Maybe it's high priority, it's a new, it's overdue. You can also see the all jobs, your jobs as well. So for the first notification that I said, I connected the survey 123 with a webhook to Microsoft Outlook with Power Automate. So I set up that survey 123 trigger that sends a notification to the first recipient in this workflow. And this shows that the ArcGIS system can actually be integrated with any other solutions out there. So for example, I've got someone fill that form and I got that notification. I can create a job. So one instance of a workflow is a job. I can create a job and assign different tasks to different people. So on my group, before I set this up, I specified who was to join on the members. So let's say I've chosen Nicolas Kihato. So it will actually notify him. And as you can see, this is a tab of Nicholas's workflow tab. He can access the work itself and he will get a notification. And you can also, just a bit, you can also set a send email step for each and every step so that the workflow notifies the next person by configuring an SMTP server and setting an email template. So for this instance of workflow manager, we saw that it's a submit, review, complete, and deliver. This is a form, but I'll just brush through because of time. You can see the different types. People can come in, specify the end type, the estimated carbon sequestration, the developer's contact information, the different documents, all the way to the end. This is page 6 of 10, so it's a lot. But you can also set this as required. So I'm just brushing through because I've set this for demo purposes. So for the ArcGIS Pro demo, let me stop sharing my screen. So let's say I'm the GIS team and I've gotten a notification that I have a job. You'll come to the view pane and access the workflow here and see the due jobs and the jobs that you're supposed to do, given the different steps of what's verified and what's not and what you're supposed to do. So let's say, for example, this is just for context, this is Mikoko project. It's a blue carbon project in Gazi Bay area for restoration of mangroves. Mangroves are among the highest carbon sequestration types of trees. So for this, I used Landsat data, which is open source, to compute NDVI, which then I used to estimate the diameter base rate raster because I didn't have the field collection, the field data rather, which then I used to estimate the above ground biomass. For this, I used ArcPy in notebooks. I'll show you an example of a 2010 raster. So I did both 2010 and present to compute the change between the two. So I used ArcPy notebooks to automate geospatial, which is very useful in automating geospatial workflows and helps in streamlining data processing. Instead of having to rewrite this code or redoing the processes again and again, you can always give this to maybe the next person who needs it. They only need to change the different workspaces and different coefficients. So I also used, in step number 2, I use allometric equations. And these are mathematical models that estimate carbon stock based on tree measurements. That's why I needed the DBH. These equations help in converting NDVI-derived vegetation data into accurate carbon estimates, ensuring it's scientifically backed on carbon credit verification. So these equations and the coefficients I was using, I got them from scientific journals that were done on East African mangroves. So for example, we come back to this project. So I did the NDVI, then the DBH, then the above ground biomass, then the carbon raster. So if I'm to show, this is the pre-2010, and the post-2010. So let's say, for example, you're not able to, estimate with the naked eye if there's an increase. You can use zonal statistics, as a table. It's an image analyst tool that summarizes the value of a raster within the zones of a raster dataset and reports the results as a table. So I'm able to interact with different types of statistics and view if the sum for the post-2010 and the pre-2010 table is adding up to an increase. Another good example will be Kasigao, which is a project in Taita Taveta. And if I'm able to take you through the before, this is before. This is before. It started in 2010 as well, and this is after. It's taking some time. Okay, yeah, that's after. So you can see the different changes. And if you can't see with the naked eye, you can always use image analyst tools to compute the change. So let me go back to my initial presentation. So the key benefits of this is a faster approval process because it automates workflow for verification and certification. There's also increased transparency because of the real-time access to carbon credit data. We also have improved monitoring accuracy because we're using GIS-based change detection to ensure there's a valid carbon sequestration. And this also strengthens our global climate commitments. Thank you for that. And I invite any questions that you might have.
Thank you, Mercy. Thank you to all presenters for the nice demonstrations. I think we are going to invite questions from the audience. And for this, I will hand over to Rachel to moderate that. So thank you.
Thank you, Sydney. Thank you, everyone, for that wonderful presentation. I can see one question on the chat section. I don't know, it's for Albert. It's from Enoch from Liberia. I think it's directed to us as Esri Eastern Africa because he asks, do you have short courses for people who are interested in learning GIS? Yes, we do have short courses. I think I'll share a link for you or for our training page so that you can go explore more. I hope Enoch is still with us. I will be sharing a link in the chat section for the same. I am not able to see any other question from the chat section. Maybe the audience, do you have any other question? You can raise up your hand.
Yes, I can see there has been a hand up, I think from Edward. Maybe you can allow him to ask. Also, we have Talia, who had a hand up for the longest time. So Talia, I think you can ask the question. You can unmute your mic and ask. Thank you.